Bismillahirrahmanirrahim. So this is the second part of the 7th lecture of statistics and probability theory. We will continue with the topic measure of dispersion. As we have already discussed that there are two types of measure of dispersion, relative measure of dispersion and absolute measure of dispersion. Up till now we have discussed how to find out range, mean deviation, quartile deviation, and their relative measures as well. Now we will going to learn variance and standard deviation. The variance of the set of observations is defined as the mean of the squares of deviations of all the observations from their mean. The positive square root of variance is called the standard deviation. If you concentrate on the definition, so what is it's saying that the variance is the set of observations is defined as the mean of the squares of deviations of all the observations from their mean. It means that let's suppose that x is a variable and mean is x bar. So deviation is x minus x bar, and they are saying the square of deviation, so it means that you have to take the square, and it is the mean of the square of deviations. So for the purpose of mean, what we do, sum of all the observations divided by total number of observations. Let's suppose the total number of observation is n. So this is the variance, and standard deviation is the positive square root of the variance. So we will take the standard deviation of the variance. It will give, by taking the square root of the variance, we will get the standard deviation. So what is the difference between the variance and standard deviation, as we are only taking the positive square root of the variance? So what is the purpose of the standard deviation? We will discuss it in coming up slides. To study the characteristics of the data set, we have two types of measures. One is parameter, and the other one is statistic. Keep in mind that this is statistic, not statistics. So this is statistic. Whenever you study the characteristic of a population, then you are basically finding out the parameter. And whenever you study the characteristic of a sample, you are basically finding out the statistic. For example, whenever you calculate the mean of the population, so we usually denote the parameters with Greek letters, and for the mean we have mu, and for the sample we use x bar. Similarly, we denote the total number of observation in sample by small n. In population we usually denote it with capital N. So for the case of variance, we denote it with sigma square, and the sample statistic is S square. So the population variance is sigma square is equal to summation x minus, as we are taking the deviation from the mean and the population parameter of the mean is mu. So x minus mu whole square over capital N. This one is for the population data. And if you are discussing the sample, so this would be S square is equal to summation x minus x bar whole square over n, which is small n. Remember that this one is the parameter and this one is the statistic. And this one is for the ungrouped data. Both of these are for the ungrouped data. We usually deal with the sample, so we concentrate on this formula. This one is for the ungrouped data, and for the grouped data, this would be S square is equal to summation F X minus X bar whole square over n, which we can write as summation F. By opening this square and by simplifying this, we can also write it as summation F of X square over. So this is the formula for the calculation of the variance. And if you want to find out the formula for the standard deviation, then this would be equal to S is equal to, as standard deviation is the positive square root of the variance, so this would be under the root F. This one is for the group data. If you want to find out the standard deviation for ungrouped data, so this would be equal to S is, and this could be written as under the root summation X square over n minus summation X over n whole square. So this is the standard deviation, and this S square is the variance for the ungrouped data, and this one is the variance for the group data. And you can write the standard deviation in this way also, under the root summation F of X square over summation F minus summation F of X over summation F whole square. So what we have discussed in this slide, that we have parameter and statistic. Parameter is basically to find out the characteristic of the population, and statistic is basically to find out the characteristic of a sample. We usually in real life we deal with the sample data, so we will use these all notations for the calculation. And S square is equal to summation X minus X bar whole square over n. This could be written as summation X square over n minus summation X over n whole square. So this is the other way to write this formula. Both will give us the same result. So this is group and ungroup formula for the calculation of the variance and standard deviation. But why we are using variance and standard deviation, as standard deviation is only the positive square root of the variance. So now let us take this numerical example. these are the marks of 9 students in an exam, and we denote it with xi, 45, 32, 37, 46, 39. Keep in mind that variance and standard deviation are absolute measure of dispersion. If they are absolute measure of dispersion, it means they involve unit in them. So now, if you want to find the variance, what would you know? You should know S square is equal to, I will use only one formula. You can use both of them. Both can give the same result. You can use for the sake of verification. I'm using this one, summation x square over n minus summation x over n whole square. So what we will get, this would be equal to summation x square. This is the column of x square. This one is 45 square, 32 square, 37 square. Whole the sum is, this is the sum 14632. This one is 1, 4, 6, 3, 2 divided by 9, as there are 9 observations, minus summation x, which is 360, as it is given in the column of the x, divided by 9 whole square. So what would be the variance? So variance will be 25.78, and as this is the absolute measure of dispersion, so this is 25.78 marks square. Why? Because this is the sum of x square and this is the column of the marks. It means we are squaring the variable, and this one is sum of x over n, again square. So this would be 25.78 marks square, as this is s square. To bring it back to the original unit in marks, what we will do, we will find out the standard deviation, which will be under the root 25.78 marks square. So this is S is equal to 5.08 marks. So this is the standard deviation. So this is the purpose, to take the standard deviation, that is we are taking the positive square root of the variance. So this is the way to find out the variance of the ungrouped data. As this is the ungrouped data, you can use the other formula as well. This one is summation x minus x bar whole square over n. Under the root, it will definitely give us the same result. Now, variance for the group data. This is the group data. These are the weights, and this is the same data as we have discussed in previous lectures. These are the weights of the 60 apples, and we have already made their classes and class mark and frequency. We have discussed in the lecture of measure of central tendency. I am taking the same table to find out the measure of dispersion, which is the variance. And what would be the variance? This would be S square is equal to So this is the variance 1216 gram square. We got this by substituting the values summation f of x square, which is 973335, and divided by 60, minus summation x f of x, which is 7350, divided by summation f, which is 60. So variance is equal to 1216 grams square. And by taking the positive under root, standard deviation is 34.87 gram. So this is the variance and standard deviation for the grouped data. Coefficient of variation. This is basically the relative measure of the variance, or you can say the standard deviation. This uses the standard deviation and mean to measure the variability of the data set. Basically, we are studying the measure of dispersion, and dispersion usually calculate means that how much the data is dispersed around the central value. And this is basically the measure of variability in the data. So coefficient of variation, what it do, it uses the standard deviation and mean to measure the variability of the data set. It gives a relative measure of variability in the data set, which is, we usually denote the coefficient of variation with C dot V. And this one would be equal to S over X bar into 100. States how large the standard deviation is in comparison to the mean in percentage terms. So coefficient of variation is basically the relative measure of the variance or standard deviation, and it usually shows the how large the standard deviation in comparison to the mean in terms of percentages. If we define coefficient of variation is also used to compare the performance of two candidates or of two players given their scores in various papers or games. The smaller the coefficient of variation, the more consistent is the performance of the candidates or players. Obviously, coefficient of variation is usually the measure of variability, and consistent means that there would be not much change in the performance. And if the coefficient of variation is small, it means that there is a lesser variation. And if the coefficient of variation is higher, it means that there is variation in the performance of the candidate or player. Thus, it is used as a criteria for the consistent performance of the candidates or the players. It should be noted that this coefficient is unreliable when the arithmetic mean is very small. So let me explain this with the help of the example. Goals scored by two teams, A and B, we named them as A and B, in football seasons were as follows. These are the number of goals scored in a match, and we denote it with small xi. 0 means that the team scored the 0 goal. 1 means 1 goal, 2, 3, and 4. And number of matches, A and B, for the team A and B. This means that in 27 matches, team A have scored 0 goals. And in 17 matches, team B have scored 0 goals. Similarly, in 5 matches, team A have scored 3 goals. So this is basically the discrete grouped frequency distribution. This is the frequency for the team A, and this would be the frequency for the team B. What you have to find out? You have to find out that which team is more consistent. So if you are thinking in this way, that which team is more consistent, you have to find out the variability in the performance of the team. Now, for the sake of variability, we should go for the measure of dispersion, and it is preferable to use the relative measure of dispersion, so we are going to use the coefficient of variation. So now these are the team A and team B calculations to find out the mean and standard deviation, as we are going to find out the coefficient of variation, and you know that coefficient of variation usually equal to S over X bar into 100. So we need a standard deviation for both of team and means of both teams. So here we have calculated, this is the mean for the team A, X bar A. I have used subscript in the statistic to discriminate between team A and team B. So this would be summation f of x over n. This is 1.06, and standard deviation for the team A is summation f of x square over n minus summation f of x over n whole square, and by calculating it by using the formula, we will get 1.308. Now you know that coefficient of variation for the team A is SA, which is the standard deviation for the team A over X bar, which is the mean of the team A into 100, and standard deviation is 1.308, and standard deviation and the mean is 1.06 into 100, so this is 123.4%. Similarly, for the team B, we should use subscript in the statistic. This is 1.20 and standard deviation is 1.308. By using the formula of coefficient of variation, we got 109.0%. So as you have to find that which team is more consistent, it means that which team has lesser variability in its performance is more consistent. So coefficient of variation for team B is 109 and coefficient of variation for team A is 123.4. So as the coefficient of variation for team B is lesser than the coefficient of variation for team A, hence team B is more consistent than team A.